For this example, I have KOH, potassium hydroxide, in water being added to aqueous hydrochloric acid, and I want to predict which products are going to be formed. Before I even write out products, I need to recognize what type of reaction this is, whether it's a single replacement, double replacement, or combustion. And because I see a compound being added to a compound, I know that this is a double replacement reaction, and I know that I'm going to be forming a new compound being added to another compound. So this is double replacement. I'm forming two compounds, and what I like to do is I like to take my ionic compounds and I like to break them up into their cation and anions. So if I take KOH and I break it up into its ions, its cation and its anion, the potassium part is K+. It's because potassium is in group 1 and everything in group 1 has a +1 charge. And then I have OH. Don't break up O versus H. OH is hydroxide. This is on the back of your periodic table. Hydroxide has a -1 charge. As for HCl, this breaks up into H+, the hydrogen ion, and chloride ion. So in every double replacement reaction, your cations, your positive ions, they just switch places. That's why we call it double replacement. Two things are switching places to form two new compounds. The two compounds are going to be one that's made from K+ and its new partner, Cl-, and H+ and its new partner, OH-. Now, we always write our compounds positive in the front, negative in the back, so don't write ClK, it's KCl. These two charges cancel each other out, so I have a formula of KCl, and this is HOH, hydrogen and hydroxide, but better known as water, H2O. Now, if I want to be an extra great chemistry student, I want to get out my periodic table and I want to flip it to the back on the solubility of common ionic compounds in water, that section on the back, and I want to look up the solubilities to see if these are aqueous or they are precipitates. Now, KCl, if you look at the chlorides, they are soluble, so that's aqueous, plus all compounds with alkali metals are aqueous. And then water. We can say water is a liquid or we can say water is aqueous. I've seen both representations. It doesn't matter to me. So here is my full equation. It's actually all balanced out for predicting these products. Now, I just want to add on a few other things, facts about this type of reaction. We didn't talk too much about this in class, but I definitely want to throw this out. This is also known as an acid-base neutralization reaction. So this is an acid-base neutralization reaction. The reason why we say it's neutralization is because water's neutral, and this is what we consider a salt. A salt is also neutral. There's a misconception that anytime in chemistry we say salt, that's NaCl, but NaCl more specifically is table salt. Salts in chemistry are your ionic compounds, so just make sure you understand that misconception. In neutralization reactions, you always have an acid plus a base forming a salt, I'll put that in quotations, plus water. These are also double replacement reactions, but it's a very specific type of double replacement reaction. Acids, as we know, start with RH+, just like hydrochloric acid. And this might be new to y'all, but just in case it's not, or it is, bases end in hydroxide, typically, not always, but bases typically end in hydroxide, just like what you see in KOH.